In the very first pair of problems, we're asked what is the value of each expression. We've got the 7th root of 1. Well, that means what number times itself 7 times will give us 1? Well, that would be 1, because 1 times itself as many times as you want always equals 1. The next problem says the 4th root of 16. Well, that's on our list of numbers that we learned. We know that 2 to the 4th is 16, so the 4th root of 16 is 2. Now, this number is a good opportunity for us to introduce this definition up above. B to the 1 over n is equal to the nth root of b. Let's see what they mean here. When I have the 4th root of 16, we discussed that that's like the 4th root of 2 to the 4th. 2 to the 4th is another way to write 16. Now, 16 had a power of 1, but 2 to the 4th has another power. Written in the long version of this definition, this power is 4. So I want to show you what the rational exponent can do. Instead of having a number written with a radical, I could instead write it using this funny notation where the numerator is the power and the denominator is the index or the root. So notice our power is 4. So this is 2 to the 4th over. Our index happens to also be 4. Well, 4 divided by 4 is 1, so this is 2 to the 1st. Notice 2 to the 1st is equal to 2. So based on this one example, it seems like that definition does ring true. So let's try using this definition. Our next set says simplify each expression by first writing them in radical form. So first we have to write each of these problems in radical form. Now the first one has an exponent of 1, so it looks just like this, b to the 1 over n equals the nth root of b. So notice my denominator tells me my root. So I'm being asked to take the cube root of 27. Now let's also write the other one in radical form, and then we'll come back and simplify. In the longer form, we have a power on top, in this case 2, and a root on the bottom, in this case 3. So we're being asked to take the cubed root of 8 squared. Now, I also have another way that I could write this, which is the cubed root of 8 all squared. Now, in this problem, it doesn't really matter which way I choose to write it in terms of level of difficulty, but in some problems it can make a big difference. Let's look at how we would simplify based on the two different ways we could write it. In the first way, we would say the cubed root of 64, because 8 squared is 64. And 64 is on our list of perfect cubes. We can see that the answer is 4. But if we do it the other way, it's actually a little easier. We know that 8 is also on the list of perfect cubes. The cubed root of 8 is 2. So I could just say 2 squared is 4. I get the exact same answer no matter which way I do the problem. Let's go back and simplify the first problem in this section, the cubed root of 27. You know that the cubed root of 27 is 3 because 27 is 3 cubed. We're also sometimes asked to take a number that's already in rational exponent form and rewrite it in radical form. And we really have to be careful about what we put under the radical. Notice in the problem on the left, the power of 1/3 is only on the x. So this 27 is not affected by that power at all. The numerator is just 1, so it's just x to the first power, or x. But I'm being asked to take the cubed root. So this is 27 times the cubed root of x. That's been rewritten in radical form. Now the next problem is almost exactly the same, except at the presence of parentheses. These parentheses tell us that that power of 1/3 applies to both the 27 and the x. So when we take the cubed root, it's of both the 27 and the x. Now it didn't ask us to simplify, but if we chose to, we'd be like, hey, wait, I can take the cubed root of 27. It's 3. But I have no idea what the cubed root of x is. So the x would have to stay under the radical. That was not part of the instructions for this particular question. I just want you to be aware that it can be done. In the next section, we're being asked to first write each expression in exponential form. So that's how we'll start. Then we'll come back through and simplify. So we have 3x in parentheses. It's all being raised to the 8th power, and then we're taking the invisible square root. So this is 3x to the power of 8 over 2. Power on top, root on the bottom. But when I see 8 divided by 2, I can't leave it that way. I know that this is 3x to the 4th power. So we've rewritten this problem in exponential form. The next question says the cube root of 64x squared. So the cube root is applied to both the 64 and to the x squared. But the square is only on the x. So the 64 and the x will end up with two different exponents. 64 is to the power of 1/3 because the 64 didn't show a power, so it had an invisible power of 1, whereas we were taking the cubed root, so we see that index of 3. X is being raised to the power of 2/3 because we already saw that it has a power of 2, and now we're also taking a root of 3. So that's rewriting it in exponential form. The next problem is very similar. 32 has a power of 1/5 because we're taking a root but not raising it to a power. And then the h has a power of 7/5 because it already had a power of 7 and then we had to take the 5th root. The last one's kind of interesting. This is x to the 1/4 power times x to the 1/4 power times x to the 1/4 power times x to the 1/4 power. Well, you know that when you multiply with the same base, you add the exponents because we talked about that when we studied laws of exponents. So this is x to the 1/4 plus 1/4 plus 1/4 plus 1/4. And you're like, wait a minute, that's just x to the first because 4/4 is equal to 1. So interestingly, the 4th root of x times the 4th root of x times the 4th root of x equals x. First, we rewrote it in exponential form, and then we went all the way through and simplified. Let's go back and simplify the other ones in this set of expressions. Notice in the first problem it says 3x all to the 4th power. Well, that power has to apply to everything in there, which you know from your laws of exponents. 3 to the 4th is 81, and then we have x to the 4th. The second problem in this section, you know how to take the cubed root of 64. You know that that's 4. The x has to keep its power. 32 you know to be 2 to the 5th. So the 5th root of 32 is 2, and the h has to keep its power. Did I really not start that? Oh, no, I did start it. Okay, good.